It's never been easier to make your own components with UI Toolkit. Earlier versions, pre-Unity 6.5, there was a lot of boilerplate that made it clunky and weird to write. Now with 6.5 and on, we can use the UXML attribute. That allows us to create our own custom controls without all the boilerplate. That helps us streamline the process and make it go much faster. In this tutorial, you'll learn how to make your very own UI Toolkit components with modern UI Toolkit and the power that brings to your fingertips. Hey, Chris here from LlamAcademy, here to help you. Who? Me? Yes, you! Make your game dev dream become reality by helping you build your UIs faster. This is somewhat of a confusing topic if you're just Google searching or YouTube searching for how to do it, because there's the old way that's clunky and kind of weird to write out. There's also this new way, and there are templates and there are custom controls, and there's just a lot of things that seem like they're competing to do similar things. Let's start with why bother with custom controls. If you already know why, you can use the chapters at the bottom of the video to skip forward to the part that you're most interested in. So why bother? Well, in my opinion, there are two main reasons that we would create custom controls. Number one, you have some idea of some control or something you're going to need to put a whole bunch of different times on the UI, maybe on different screens, maybe in different scenes. The key thing here is we want all of them to look and behave the same. Imagine using a button. Generally speaking, we want all buttons to pretty much look and feel and behave the same. We don't need a lot of extra functionality. We want to just be notified when the button's clicked. Maybe we want to disable it or enable it, but that's pretty much all the functionality we're looking for in a button. Now, Unity already gives us a button, thankfully, but that's the type of control that we're talking about for use case one. Number two is sometimes we have more complex controls. Imagine an inventory panel as an example, or even your worn equipment in an RPG. It's possible and maybe even likely that we want to show what the character is wearing in different scenes and stuff, but we want to look, behave, have all the same controls, and we don't want to have to copy paste a whole bunch of stuff. That sounds like we have a reusable component we'd like to put in multiple places. And it's distinctly different from option number one in that we need to give it a bunch of functionality. By creating a custom control, we can encapsulate all of that common behavior, all that common functionality, and be able to inject that into UXML with a single line of UXML code. Now we don't need a bunch of different classes that all need to know how to do the same thing. We can encapsulate it in that single component class. When then should we use a template versus a custom control? Once we've decided that, we'll take a look at how we can implement both of them so you have all of the tools you need to get started. Number one, templates. Templates are great for display-only elements where we don't need a bunch of logic baked in. Frequently in games, we might have an HP bar or an HP orb or a mana orb, something like that, where we're just trying to give information to the player. And we may need to do that in several different areas. By using data binding, we can set up all kinds of configurability in how it's displayed. Maybe when you're full health, you have green health, and as it goes down, it goes to yellow and then red. All that can be controlled through data binding, so that's fine, but we're not adding functionality to this element. The core distinction for me is I don't need a backing class for this template. We just instantiate or insert that template into our UXML, and we're done. Everything should just work. Maybe at worst, we have to assign a data object for our data binding, and then it's done. If this is starting to feel a little bit complicated already and you want a guided introduction to UI Toolkit, check out my brand new UI Toolkit Fundamentals course, linked in the description and the card on the screen right now. That'll get you confident in building good-looking UIs with UI Toolkit. You'll learn about UXML, USS, data binding, animations, and more. Let's move on to talking about custom controls. We want to create custom controls when we have more complex objects than what we can accomplish with just a template. There's some extra special logic that needs to happen. The worn equipment panel is an example. In this video, we're going to take a look at an XP drop, which might initially sound like, oh, well, the XP drop just shows up on the page, but you probably want to remove it from the page. So what we're going to do is make the XP drop show up and automatically remove itself after some time. That's some fancy custom logic that would be hard to do with just a template. And I do want to clarify something before we dive too deep. You can use a custom control in place of a template because a custom control has all the capabilities that a template has and more. It just means that you're creating a dedicated C# class for something that is a little bit irrelevant because you're not adding any behaviors to it. That's why I recommend you use templates when you just want to show something, and use the custom controls when you want to add behavior to that display. In both cases, it's when we want to reuse them in multiple different areas. Still with me? Let's dive into Unity and make both a template and a custom control. If we come in here into Unity, I'm using Unity 6.6 beta at the time of this recording, but whatever we're about to look at works in 6.5 and on. The first thing, if we want to use UI Toolkit, is we need to make a panel renderer. That's just right-click, UI Toolkit, panel renderer. I already made one that has an empty runtime UI just to get us started. I've also attached an input handler script. That's going to make it where when we left-click, we will spawn an XP drop just to show how it's going to work. I also made a health scriptable object that we're going to use to bind to the UI on our template so we can see some of the power of using a template with data binding. Let's start by taking a look at this UXML for maybe a health orb. In this case, I call it a stat orb that just has a visual element in the background and a fill, where if we adjust the height of this fill, we'll see it's going to fill up that orb. The styling and all that I used here is not super relevant for this tutorial, but you can check out the full project for free on GitHub, link in the description to that if you want to see exactly how it's made. The important part of this is that we have made some UXML, dedicated UXML document called stat_orb that we put somewhere in our project. In this case, it's right next to our runtime UI, but it doesn't really matter where it is. Any UXML document can be used as a template. If we open up the runtime UI in UI Builder, and over here on the left on our library, if we go to project, we'll see every UI document UXML that we have. Here we have assets, LlamAcademy, scripts, UI, and here we have both runtime UI, which we of course would not be able to inject the current document into itself. That would break the universe. But we do have the option to put a stat orb. We can drag these into our hierarchy the exact same way that we do any standard visual element. It creates a template container. And don't worry, we're going to take a look at the UXML in just a second for this. We can even style our template container. In this case, let's make it a size of 75, square size, and position it absolutely. That's going to be position mode absolute. Let's give it maybe 50 pixels from the top and 50 pixels from the right. So it's positioned here at the top right. And we can just keep making more of these if we wanted and put them in more and more places on the screen. Maybe if we wanted health, we could do that as well and just change the data binding. So already we're seeing it's very easy once we've created a UXML element that we'd like to put into another one. All we need to do is come to our project and drag it in just like any other standard component. That's part of the power of a template. Just as an example, if we come to standard and use something like a scroll view and drag that in, you'll see that it behaves the exact same way. The scroll view here, we can expand, but we can't modify the stuff inside. So we can see that a lot of the custom controls that we have available here may be custom components or templates as well. I'll remove the second orb. We're just going to deal with one for now. The thing that we really want to see the power of this template is the data binding, because we will likely want to use this health orb. Let's even rename it health orb. And then let's open up that stat orb UXML one more time to see how we can use the data binding to get this power. The way data binding works, we go into this in depth in the UI Toolkit Fundamentals course. But the short answer for us today in this video is we want to manipulate our size, our height specifically based on the health scriptable object value. So over here in our size height, if we just click over here on height and say add binding, it gives us this little window and we can say, hey, I want to be bound to a specific object. I want to use that health scriptable object right here. And I want to use the health. Go ahead and say add binding there. Now, if we save our UI builder, notice already it is not the full height. So we can adjust our health here and see, oh, 0 negatives, we're dead. And as we go up, it fills up. In this particular case, because we have 75 pixels tall, once we hit around, and a little bit of padding in there, once we hit around 68, 72-ish pixels, it looks maxed out. But there are techniques we can use to set the min and max value. So if we have, let's say 1,000 health, it would properly go from 0 to 1,000 to fill up instead of it being capped to whatever the particular height of this element is. So cool. Now we see our template gives us the ability to very easily inject elements by just dragging from our library. All we have to do is define a separate UXML document, and we can just start dragging them in as templates. I personally prefer to write the UXML by hand rather than to use UI Builder. So this is how we do templates with UXML directly. We first define a UI template and specify the source for that template. In this case, because we used UI Builder, it uses this project database stuff and adds all these like file IDs. But if you're writing it by hand, you can do it just like this as well with just source equals and then the path to your particular file. By giving it the name statorb, we can then use the UI instance with the template value of the name of the template. So right here, our template name must match this one. And that's how it knows to pull this UXML file and inject it right here into our template container. We can then style, like what we see here, the template container to make it look like what we want and position it where we want to. Then in our statorb, as an example, we would be able to handle any internal styles we'd like with our own USS, and it fills the template container. That's all there is really to know about templates. We just define our little piece that we want to be reusable in a dedicated UXML document. Then on the other UXML that we want to inject it into, we use that template tag with a specific name. And then for each instance of that template that we want, we use the instance tag. Now let's take a look at making a custom control. This is going to be markedly different than anything you've seen if you've watched tutorials in UI Toolkit pre 6.5. I've already made a UXML document here for an XP drop that we want to use for our custom control. So right now with just this, in our runtime, we would even be able to see, I just put in different location, resources, UI, components, XP drop. We can still drag that in here just like a template, but that's not going to give us the behavior that we want. We want some behavior with this as well, and we want it to be self-encapsulated. So let's remove that template container for the XP drop, but let's add a visual element here called XP drop container. Let's also make it positioned absolute. On the left side of the screen, top left should be good, and just give it a width of like 200 pixels and a height of 100%, so it takes up that full height. That's just going to be important because we want them to be contained over here on the left side. It's not necessarily a specific fancy thing for custom controls as a whole. I did say that we need a backing class for our custom controls. So here in our scripts UI folder, we'll go ahead and just make a new monobehavior script. It's not actually going to be a monobehavior, but that's what Unity's calling it in the menu. And we'll call it something like XP drop. Once we get in here, we can get rid of that default monobehavior stuff. And the first thing we want to do is change the XP drop to not be extending a monobehavior, but extend a visual element. This is how we make our own custom controls. The most important thing is we extend the visual element. We then attach an attribute to the class, UXML element, and immediately complains at us because this attribute generates code and requires that we make it a partial class. By marking it partial, it allows Unity to create their own XP drop generated class, and it merges those two together when it compiles. Now, a pattern that I like to follow for this is when we create a new XP drop class, a new visual element, we clone our UXML into the current element, this one, and then we find any elements we need to set up or anything internal state that we want to find or manage. And then we can expose functionality through public methods, just like what you would do for any normal class. Let's see what that looks like. We first make a public XP drop constructor, and we just want to load our UXML. And we intentionally put this in resources UI components so we can load it at runtime from this class. So when we're making custom controls, my preference is to put our UXML documents in the resources folder. So we can do resources.load, and then the path to them is just UI components XP drop. You can see right here, Ryder is suggesting UI components XP drop. Ryder's smart enough to be intelligent about knowing what's in your resources folder, where are these things, what do you have available, so it's a lot faster to write out your code. I personally feel Rider is the best C# IDE for you to use for Unity game development. There's so many features like that that just make your experience so much better. I've got a code that you can save 25% on an annual subscription using code LlamAcademy at checkout. Check out the link in the description for that. Once we've done resources.load our visual tree asset, we need to keep track of it. I call it visual tree asset template equals resources.load that visual tree asset at that path. Then we just do template clone tree into this. And that's the extent of our boilerplate code. We just make our partial class, we make it extend visual element, attach the UXML element attribute, and then make a constructor that loads that template and clones it into ourselves. At this stage, we have not done anything different from a normal template. All we've done is given ourselves a named way to inject a template. And let's take a look at our input handler just to show what I mean by that. So on our input handler, let's say that this requires a type of panel renderer. I'm just going to quickly go through the setup of how we attach a model behavior to a panel renderer. Again, this is covered in depth in the UI Toolkit Fundamentals course. We make a private panel renderer. On awake, we go ahead and get that panel render off the game object and register a UI reload callback, handle UI reload, go ahead and create that function. And the important thing we want in this case is we want to put all of our XP drops underneath that one XP drop container. So we're going to want a private visual element XP drop container. And we want to assign that on this handle UI reload. XP drop container equals the root element dot q for the, here we go again, XP drop container. Rider is just smart enough to know what's in our UXML to recommend these for us so we don't typo stuff on accident. And of course, on destroy, we also want to do panel renderer, unregister UI reload callback, handle UI reload. Once we have our XP drop container populated, on update, we can do something like instantiate our XP drops when we left click. That's just so we can see that this stuff is working. In your own game, you would have like an event or something that happens, hey, you gained XP, and show it on the UI. We'll do if mouse current left button was released this frame to tell if we've left clicked. Then just do XP drop container dot add to add a new visual element as a child. And we can just do add new XP drop because XP drop is a visual element. That's what I meant by we've just created a named template so we can add them just like this with a new XP drop instead of having to do stuff like cloning templates and whatever. The cloning template behavior is already done here in our visual element. This piece that we see in our XP drop is the same thing you would do if you wanted to instantiate a template at runtime as well. We even call it template here. So nothing revolutionary so far. What really we get some cool power from is, well, an XP drop probably needs to have an amount that they're getting the XP for. So just like what we would do for any standard C# class, we can add functionality through public functions. So let's do a public void set amount that accepts an int amount. And we want to show on our label this amount. Well, we don't have that label yet. So let's just come up here to top and do private label. And once we've cloned our tree, we can query our current visual element with this.q. So we can do label equals this.q label. And now in set amount, we would be able to set the text based on this amount. The real power from this custom control is starting to show. No longer does anybody who wants to show an XP drop need to understand that it has a label and we need to query for it and we need to set the text to some amount string whenever that happens. It's all encapsulated here. So on our input handler, when we left click, let's say we want to give it just a random XP amount. So we need to get a reference to this first. We'll just do XP drop equals new XP drop. Then we can add the XP drop. And now that the XP drop is mounted into our panel renderer, we can do XP drop set amount. Let's just do random range, let's say 1 to 200. So we'll give ourselves a random XP 1 to 200 every time that we left click. We want to do it this way because when we do set amount, we're manipulating some visual tree stuff. And Unity will complain at us if we try to do this before that element has been mounted onto the UI. That's why we want to make sure we first add it and then manipulate it. If we then come back to Unity, we can just click play. And if we start left clicking, we'll see up here at the top left, we get that random XP amounts getting added. We've already gotten some benefit from having a custom control in that every single thing that needs to show an XP drop no longer needs to understand the structure of the XP drop to set the amount. They just call .setAmount. However, we would probably like these to go away after some time, which is a native behavior that would be great if XP drop handled itself. We can do that because we have our own custom control. In the XP drop class, if we want to wait some amount of time, because we're not on a mono behavior, we can't do something like start coroutine because it's not a mono behavior type. Instead, we have the ability to do schedule.execute. We can execute any arbitrary function here. It can be defined on this class, or we can use one that comes natively from Visual Element called remove from hierarchy, which will do exactly what it sounds like. It'll remove us from the hierarchy. And we can say execute later. And how much later? Well, that depends on your preference. We'll do 2500 milliseconds or 2.5 seconds. Now XP drop has even more functionality baked in. Every time it's added to the UI, 2.5 seconds later, it'll automatically remove itself. That's something we couldn't really do with just a template. Coming back into Unity, play. If we click once, we'll see up here this top, oh, there it goes away. And we can spam click and we'll see all of those get removed 2.5 seconds after they were added. That's a pretty neat effect. Of course, you can do much more than this. You can animate the XP drop, you can add more functionality, you can bind a scriptable object skill to it so you can see the little icon. At this point, whatever you want to do, you can add in that functionality because you know the core underlying mechanics of how to create your own custom controls now. If you got value out of this video, make sure you've liked and subscribed to help the channel grow, reach more people, and add value to more people. And if you want to show your support for this channel, you can purchase the UI Toolkit Fundamentals course I've mentioned a couple of times. You can get yourself some LlamAcademy merch right here on YouTube. You can use the affiliate links down in the description to purchase Humble Bundles, Unity Asset Store assets. I know you're going to buy some assets anyway. That'll give me a small percentage of the purchase price at no additional charge to you. And of course, you can also become a Patreon supporter or a YouTube member. Your recurring monthly contribution there is greatly appreciated, and you get some pretty cool perks, like getting some access to behind the scenes videos, to a private members exclusive Discord. And of course, at the end of every video, you'll get your name appear on the screen. And starting at the awesome tier, you'll get a shout out like these awesome folks: Ethiopolis, Jason Hansen, Snedden, Mustafa, Nick5454, and Pixel Wizards. There's also all of these great supporters as well. Thank you all for your support. I'm so incredibly grateful, and I'll see you on the next video.